Alright, so I think I will get started for today. So, good morning. Welcome all of you to attend for the HCIE INS. Today is on the day number 4. Okay. Yesterday we covered on the OSPF as well as on the ISIS. Okay. OSPF version 3 and the ISIS version IPv4. And today we go into the IPv6 ISIS. Okay. So before I get started, any questions related into the OSPF v3 and also the ISIS IPv4? Okay, on the advanced features and also the basic features. So let's say they have no any question, then I'm going to get started for today on the IPv6 ISIS. So still remember that I mentioned this before. Yesterday I mentioned that for ISIS to support a new protocols, they do not need to build a new standard. Like in OSPF, from OSPF version 2 to support IPv6, I need to enable the OSPF version 3. So it's the totally new protocols just to supporting on the IPv6. Okay, that is called the OSPF v3. But for ISIS over here, it's just a IPv6 ISIS. Okay, just a IPv6 ISIS. It means that they're still using the same ISIS. What they're going to add it in, they will just adding the extension. Okay, extension. So that's why that ISIS is very scalable. They can be just based on the type, length, and value. They can support and adapt a new protocols already. Okay, be very flexible for ISIS. Just like how they're going to from the OSI layers, how they're going to be integrated into ISIS. Same thing. They're just based on the TLV. So that's why in ISIS it can be integrated with anything like IP, IPv6, or not even IP address. Even you're using CLMP, they can be communicate as well by just using a normal ISIS. Okay, that will be the benefiting and the scalabilities of the ISIS. It's compared to the OSPF. OSPF, no, I only can support IP, and when you want to use IPv4, you have to use OSPF v2. When you want to use IPv6, you have to go to use the OSPF v3. So you need to use a different protocol to support the different services. Okay. So and now we look into the ISIS protocol extension. Okay. So what is the type length value they added into this ISIS to let this support IPv6? Okay. And ISIS is just as a IGP protocol. Okay. And ISIS, same thing, they're using SPF algorithm to calculate the route. They're based on the TLV, which allow the high scalabilities. And support new protocol and features, you only need to extend the TLV value and also the sub TLV value. So you create a main TLV and also the sub TLV to support the ISIS IPv6. So that simple that it is. Okay, and the structure can be easily extended to support like IPv6, traffic engineering, multi-topology, and also other functions and also other protocols. Okay, and that is where we are going through and check these two. Okay, IPv6 and also multi-topology. For the traffic engineering, this one is only when you're running on the MPLS traffic engineering. Then it's required to extend the ISIS to support. Just like to support MPLS TE in OSPF, what we're going to do, we enable the opaque LSA. We enable the type 9, type 10, and type 11 LSA to support the traffic engineering. But for OSPF, it just extend the TLV to support that, like support IPv6, traffic engineering, and also on the multi-protocols. So ISIS does not need to change much to support IPv6. Therefore, the feature is high inherency, and also the development of the OSPF v3 to support, you have to use the OSPF v3. So that will be just an overview of the ISIS on the IPv6. So that you can see that they do not have any special value, not like OSPF. They have a version 2 and OSPF version 3. ISIS, they did not have any version. It's just one ISIS. To support the IPv6, it just extended the TLV. So which extended value they're going to add in? They added in these two values. They added in the IPv6 reachability type lang value of the type 236. Okay, this is a type they are added in as a 236 to support the IPv6 reachabilities. Okay, the prefix of matrix and tag are used to describe the reachabilities of the v6 prefix and also internal external reachabilities. So for the internal route and also for the external route, okay, for the reachabilities. So this one it means that they're going to be within your ISIS, and from external when they import into the internals. That is where they are come from for the IPv6 reachabilities. All right. And for the IPv6 interface addresses, for these interface addresses, it will be very similar to the IP addresses on the TLV. So it's just that in case of they changing from 32-bit, right now they're changed to 128-bit of the IPv6 address that they're going to be representing. How they represent on the IP addresses. From 32-bit, they go up to 128-bit. For the reachability is how they exchange the route. They send this route to the neighbors. So they're going to put this IPv6 reachability into the LSP and forward to the peers. Okay, these are the two interface addresses they added in to support on the IPv6. Okay, that's simple. So you do not need to build a new protocol just to support on the IPv6. But still the same case, V6 is to V6, V4 to V4. You cannot say that I'm going to enable router A, router B. So one side over here I enable as a ISIS, IPv4. And this side are using ISIS, IPv6. So it's not possible. And even though both are using ISIS, IPv4, when you import IPv6 ISIS is also not possible. So it's still the same thing. V6 only can talk to V6, V4 only can talk to V4. That will be the standard. Okay, the standard is set at V4 talk to V4, V6 talk to V6. They cannot be interoperate yet. For them to interoperate, you need to use a dual stack. You need to using the different tunnels to let this work. Otherwise, they're still able to only talk with their own protocols. V4 to V4, V6 to V6. Although ISIS internally they can support V6 and V4, but it doesn't mean that they can interoperate. Interoperate is still not possible. Okay, V6 can only talk to V6. All right, that is the principle on the V6 and the V4. They are still independent. For them to interoperate, you have to use the tunneling or using a dual stack or using the netting to make it work. All right, these are the two extended TLV added in, IPv6 reachabilities and also IPv6 interface addresses. These are the two things they added in. So under the IPv6 reachabilities of the TLV, so this is how it look like. So they have a type of 236. The matrix, okay, they have U-bit, X-bit, and X-bit. Use U, X, and S. Reserve prefix lang, prefix, sub TLV lang, and sub TLV. So they're going to have all this information to representing that what information that you are sending. So for the matrix over here, they're going to have matrix up to 1023. Okay, of the matrix. Okay, they will just change from path matrix to the V6 path matrix. All right. So from here, they have also another three more value as a U, X, and S. U bit is indicate whether the prefix is advertised from the high level, used for a loop prevention. So to make sure that where they are coming from, up level or down level. If from up level, you only can send to the down levels. Okay. So it means that they try to prevent loop that whichever I receive, I will not send back to that location. And also by using this up and down, I also can build my topology, ISIS topology, to know that who sending this information to me. Okay. And also have an XBit. XBit is meant for the externals route. Indicate whether the prefix is imported from other routing protocols. Okay, let's say XBit is 1, it means that this is from the external route. Let's say XBit is 0, it means that this is for my internal route, is within my ISIS, or from other protocol come into the ISIS. And the last one is on the TLV, the sub TLV flag. So this one only when you want to carry multiple information or extended information, you're going to have a sub TLV 1. In this case, they're going to add it in over here and add over here. They're going to add on the sub TLV that you're going to carry into the IPv6 reachabilities. So such as what type of attribute you're going to use, what type of tagging you're going to be used, it'll be inside the IPv6 reachability, you're going to be added in from here. And another one is on the IP address, IPv6 address, interface address. Okay. So that is just similar into the TLV 132. It's on the IPv4 132. 232, it's just that right now they just extend the length from 32-bit, it changed to 128-bit. Yeah, up into the 128-bit. So this is what they're going to be sending with the interface. What interface that you have? Interface address number 1, interface address number 2. Okay, so that will be very similar into your TLV 132. And for the TLV 232, maximum up to 16 IPv6 address they can support it inside this TLV. Right? And let's say it's in the hello bucket, this interface address TLV contain only the link local addresses of the interface that send the hello bucket. Okay. So when they send this information, they need to how many information they allocated. It maximum up to 16 addresses. Okay, 16 IPv6 addresses that can be inside the interface address. And when it said hello, it always is point to point. They will just send as a link local address. For a normal LSP, for LSP information, they will include all the non-link local. Okay, for hello, they will just send as a link locals, okay, a link local address. And this is how the address structures of TLV. As I mentioned just now, there is a map from the TLV 132. 132 is supporting on the maximum 64 IP addresses. And when up to 232 for IPv6, maximum up to 16 IPv6 address are supported under a single IPv6 address TLV. And this field carry a different PDU. In hello PDU, the backend TLV only send the link locals. That's what I mentioned just now. And for LSP, they will send only the non-link local IPv6 address of the IS. Okay, this is what that you are advertising, your interface, your local interface and your interface with the non-link locals. That's how you're going to include inside the interface addresses. Okay, the one just now is on the reachabilities. Reachabilities means that include how the prefix that you can learn from others, how you're going to build this IPv6 reachabilities. Okay, these are the two different TLV that added inside the IPv6 ISIS. And from this ISIS, they also can support on the multi-topology. It will be very similar to the OSPF. Okay. OSPF, we treat on the multiplex instance. It will be very similar to the multiplex instance. So it means that under a single interface, I can running a different topology. Okay, this have to define the instant ID into the OSPF on the interface. But for ISIS, they have divided a single topology and multi-topology. Okay, single topology, it means that your V4 or using V6 is called as a single topology. So when you're using a dual stack, let's say using a dual stack, it's called as a multi-topology. This dual stack, this MT, it means that with a V4 and V6 together, okay, you're running as a same dual stack into the devices. By right, when you are using the single topology, your V4 and V6 must using the same topology. It be similar to the spanning tree. Okay, a spanning tree, you're using sharing the single spanning tree, okay, single topology. But when you move on into the MSTP, you have multi-instant. You can specify this is a root of the calculation, and this is a root bridge of calculation on the other side. Okay, this is how the differences, the similarities compared to the spanning tree. Okay, on the MT. So MT means that you combine the two protocol together. By default, single topology, they must using the same calculation. The shortest path first calculation must be the same. But using the MT, you can have their own calculation of the MT. That's how it looks like on the single topology. The same shortest path tree is constructed for all protocol using ISIS. V4, V6 topology must be the same when they are running the single topology. Let's say you're also using a dual stack. Using a dual stack, you have ISIS, V4, and V6 together running. So that is where I'm running over here. IPv4 and also IPv6 ISIS. It's been running already. So for the SPF calculation done by this physical topology, that's how it works. They're going to be forming the same topology for the IPv4 and also on the IPv6. Okay, they must be follow the same information. All right. So for the disadvantage and the advantage for the ISIS, IPv4 and V6 using a single topology, as requirement of network maintainability is growing, the one to have a maintenance network with the independent topology, they need to maintain the same shortest path tree for all protocols. So that is how it is. And the disadvantage is the single topology is not applicable to the network with the multiple topology. That is straightforward. So it means that you cannot specify the information on the other side when they want to set a different type of topology. You want to set that I want to using this as my calculation path, it's not possible because it's all based on one single calculation, only based on the single topology calculation. So you cannot have any path that you define using the different calculation. It's not possible. You must define all the device using the same technology. Okay, V4, V6 technology have to be applied, and they must form a single shortest path tree based on the ISIS calculation. Because you remember that in ISIS, we're just using one process. One process belongs to V4 and V6. So when they gather the information, they will do the same calculation. They will not split the calculation. They will just do the same calculation with the V4 and V6. All right. To maintain the same topology, all interface must run V6 and V4 ISIS simultaneously, leading to the inflexible deployment. So whichever you enable V4, you must enable V6 as well, because that you'll be using the same calculation. You must running the both protocol on the same interface, right? And IPv6 area cannot be connected through the IPv4 area because IPv6 traffic will be discussed in the IPv4 areas. So it means that you cannot say that I cannot be overflow my traffic going across to the IPv6. That is also the drawback, that you cannot just using V4 and V6 between them, because they cannot just passing through. They're not allowed the passing through using your IPv4 areas. So when you're doing that, you need to use the tunneling, or you want to use the different method of the algorithms like netting or using a dual stack to allow this. Otherwise, this cannot be done. They must be discarded. So by doing all this is a disadvantage by using a single topology. Let's say you want to use a V6 and V4 ISIS together, you always define this as a multi-topology. Okay, multi-topology allows the ISIS maintain the different topology in the routing tables. So they can have their own topology. So this is how the physical look like. But I can define this is my logical V4 topology, and this is my logical V6 topologies. So this is my way of my calculation. Okay. So even that did not configure over here. So it means that it's not necessary that I need to configure IPv4, IPv6, IPv4, IPv6, IPv4, IPv6, IPv4, IPv4, IPv6, and IPv4. So it's not necessarily need to be same on the interface. So in this case, when I say that I do not have V4 over here, and this is my path uncalculated, just like let's say you are using the single topology, they will do in the calculation for you as well, but using IPv4 calculation. But your traffic cannot be forward through this path because it's using IPv4 calculation. Okay, so do you get the meanings of this single topology and the multiple topology? Okay, multiple topology, it can adjust flexibly define which interface is running V4, which interface is running V6. It's up to you, because the V6 calculation, they do their own shortest path tree. V4 calculation, they do its own calculation. So they are not doing as one, they do it as two topology. So this one, it gives you flexibility. You do not require to perform all the V4, V6 calculation to be done. So this is how the path can be done. So it means that in V6, when I want to reach between these devices, these routers 5, router 1, router 2, router 3, router 4, from 4 to 5, I need to using this way to go to the 4. Okay, because between this, I do not have any IPv6. Between here, I also have no IPv6. Okay. So that it can be adjusted which interface need to be enabled. It be more flexible. Rather than single topology, everything need to be defined the same, V4 and V6, because they're just using one single calculation algorithm. And the calculation algorithm is identical. Is that okay for this multi-topology? The difference between single topology and also the multi-topology. So by multi-topology, to enable the topology separation, they separate the topology. So it means that at the same time, they're going to add on a different type of TLV. By support the MT, they're going to build 4 TLV, okay, just to support on the multi-topologies. They will have a 229, they have a 222, they have 235, and also they have a 237. Okay, so they will have a MT identifiers. So they have MT IS, okay, intermediate system, and also they have a MT IPv4 reachabilities, reachables prefix, and they have MT for IPv6 reachables prefix. So they're going to include all this. So let's say you have V4, V6 together, you should see the 4 difference of the TLV, okay, TLVs. So in this case, this TLV is to identify who you are. You are which of the intermediate routers. You are the routers information. Who is the MTIS, okay, and what are the route you are sharing into the V4 and V6. They split these 2 information, okay, to establish a neighbor relationship separately using the V4 reachability, V6 reachabilities, and also based on the MTSI. So I'm going to build a different neighbor relationship. Advertisement of the reachable route, prefix reachable, and the reachable routers, IS reachables. Okay, there is the 222 and also 235. This is on the 222, and this is on the 235 or 237. Okay, SPF calculation and the route calculation based on what information that you receive from 235 and 237, they do the separate calculation. They not do it as one. They're going to, based on what you have, are going to do the calculation differently. V4 have V4 calculation, V6 have V6 calculation. And to implement the isolation of multi-topology, the MT parameters must be carried in all the preceding process. SPF calculation and route calculation must be complete on a routers. Okay, so they need to do it. All the devices that involved in the MT, you need to enable separately. You cannot say that I only calculate on my side. So all the routers when inside the MT, they must support the MT topology, the features. You need to enable the 4 TLV to able to calculate separately between IPv4 and IPv6 ISIS. So that is what the minimum requirement required to perform on the multi-topology. Okay, to fulfill such as a requirement, the draft IETF ISIS WG multi-topology 11 define 4 TLV. That's what I mentioned. 229, 222, 235, and 237. You can say it's from 222, 229, 235, and 237 to support on the 4 different TLV. The type, the length, and also the value. Is that okay? To enable the MT topology, you must need to define all the routers inside the multi-topology to perform the same configuration. Okay, make sure you enable it for every single device. Otherwise, you'll be just partial. Where partial, you might found that your the shortest path tree you form differently. Because suddenly they have MT, suddenly they have a single topology. So they'll be confusing already. Okay, and your shortest path tree, it might not be identical in this case. So that is just purely on the multi-topology. And the next one, this is how we are configuring on the ISIS. IPv6 ISIS actually is pretty simple to configure. Okay, for ISIS multi-topology or just a ISIS basic. And that is a configuration command to enable the ISIS multi-topology. This is what we need to be done. IPv6 enables topology IPv6. Okay, IPv6 enable topology IPv6. That's it. So it means that you're going to enable another topology. By right, they only have a single topology. It's only IPv4. Okay, but they still can have single topology between two of them. Just that they must be defined all the v4, v6 under all the interface inside the single topology. But by doing so, you're going to enable another topology for just IPv6 to define this is on the MT. To advertising your IPv6 is just ISIS, IPv6 enables. And to check the peering, you still use back the display ISIS peer, display ISIS route. So they do not have any differences compared to OSPF v3. OSPF v3 need to always keep the keyword of the display IPv6 OSPF and so on. You need to put the IPv6 keyword. But for this configuration on the ISIS, it's just similar into the v4. Okay, just that when you're advertising your network, you need to advertise that I want to advertise ISIS IPv6 enables. Last time we just do ISIS enables, but this time you have to do ISIS IPv6 enables already. So this is one of the extra configuration need to be done inside the ISIS configuration. So inside the application case of the dual stack ISIS, what we need to be concerned on the ISIS planning. The planning on the ISIS, what information you need to do it before we configure. This is more into the design. How we design on the dual stack ISIS. On the planning on ISIS, first is on the network entity. So as I mentioned earlier on, network entity, there must be 10 byte. Yeah, 10 byte. The smallest it can be up to is 8 byte, right? 8 byte, 10 byte. Okay. So in this case, you can see that from here, the net is in the format of AABBCCDD. So from A to D, that is your area. For S over here, this is your system ID. And this is your N selectors. So the area ID, it can be any numbers. But for the AA, The value over here you put as a 49. 49 is a private area. Okay, private area. They already define this number. When it start from 49, there is a private area. And the BBBB, CCCC, DDDD, you can define like BBBB as a country code, CCCC is a province code, DDDD is considered on the site where the device are located, okay, and so on. So let's say you do not want to make it too complicated, you can just make this as a 49 0001, the first areas. All right, or you can just put the code, the postcode in your areas. Okay, but into our lab environment, we can just make it as a 001, 002, and so on, even 000. Okay, but from this is a planning. Let's say in the live environment, this is what we need to consider. And remember, for this area ID must be odd byte. Okay, must be odd byte. So you can using 1 byte, you can using 3 byte, you can using 5, 7, 9, 11, and 13 byte. You cannot use the even numbers. It means that they must start from a byte dot. Okay, they cannot be 2 byte. 2 byte, because they always start from 1 byte first. So that's why they must be odd numbers followed by 2 byte. Okay, that's why in total this 1 byte, 2 byte, 3 byte. Okay, there must be an odd byte on your area IDs. And the next one is on the system IDs. System IDs, it just can be defined as your loopback. Okay, so I really show you that how this can be converted. Okay, how it can convert back into the system IDs. Okay, because over here you can see that so this is the value of system IDs. Let's say you have an address of 192.168.1.1. Remember, I tell you that every single octet you just add 3 digits. Make sure they become 3 digits. So it become 192168001001. Okay, and this is my system ID. And refer to the IP address. I just add 00 in front, 00 in front, and map into my system ID. Okay, just the dotted difference. And the end selectors is always 00 when you are running on the IP environment. I don't care it's V4, V6 environment, they also will be 00. And the layer and the region based planning, layer 2 is always prefer. So don't use as a level 1, 2. Don't use level 1, 2. Because level 1, 2, you be, let's say you have only one single area. Don't use level 1, 2. You use all the level 1 or all the level 2. But don't use level 1, 2. Because level 1, 2, in this case, they will send the information to level 1 as well as a level 2. They send twice of the information. So this one will be just a burden into your device. Let's say you just let it to run level 1, level 2. Most of the time, we set into 1 levels. Either it's set to the level 2 or set it to the level 1, but not level 1 and 2. Okay? So that is on the network entity. Network entity is important. Without the network entity, you cannot continue, you cannot perform the changes of your ISIS. You cannot configure ISIS without the network entity. Your network entity is important point for them to perform communication, for them to perform the negotiation. It's all based on the network entities. Okay. And the next one is on the cost. The cost planning. Flexible cost planning for ISIS, the cost can be designed based on the bandwidth of the link, and the cost can determine the direction of the network traffic. Before the cost design, be clear about the direction of the network traffic in different end-to-end scenario. So you can set where the path from one end to the other end. Okay. So from here, you can define the cost. The cost, it can based on the bandwidth of the link, or it can determine direct on the interface to specifying that what cost is going to be used. And they have a default cost value of 10. Regardless of what type of link type that you're using, you can using Ethernet, you can using 10 meg, 100 meg, 1 gigabit, 10 gigabit serial connection. But they still have a default value of 10 of the cost. 10 of the cost. So that's why in this case, you need to know that which way they're using. You need to check properly the speed. And also, let's say you want to prefer one of the way, you're going to set the cost manually yourself. You need to set the cost manually yourself. ISIS support 3 methods for the setting link cost value. Setting on the interface. Set the cost for all the interface in the ISIS instance. Okay, so for all the interface that I have in my switches, in my routers, I will set a single value. Okay, all interface, or do it one by one. Automatic calculate of link cost value based on the link bandwidth in the system view. Okay, so that is the 3 method, but this one always it be just calculate as a 10. This one you can up to what you define. This is what up to you define. So these are 3 methods for us to assign the cost into the interface. Automatic, static one by one, or static for entire routers. Okay, that is the way of the method we can provide to define the define the cost. Okay, so it just depends how method which method that you are using. So far, okay, this one. Okay, for the ISIS cost planning. And the next one will based on the reliability planning. Under reliability planning, we need to look into the convergence, how they provide the fast conversion from here. So for the BFD for ISIS, rapidly detect the link fault. Okay, how fast they can detect the link fault by using BFD. BFD, there can be up to 30 milliseconds. Okay, the fastest can be up to 30 milliseconds. And ISPF, speed up route conversion, and partial route calculation, PRC. These two by default is already enabled. Okay, supported by default. So it means that when you enable ISIS, the ISPF and the partial route calculation is already enabled. Okay, let's say you want to even speed up how they perform the fast flooding. You can enable this one. This is what you can enable. How fast you are forwarding the information out of the interface. Yeah, this can be done by enable the fast flooding. And intelligent timers speed up the route conversion and improve the network stabilities. Yeah, that's on the intelligent timers. So for the intelligent timer, it can have 2 intelligent timers. Okay, one is to how fast I calculate and how fast I generate. Okay, one is on the generate and one is on the calculate. Okay, calculation and also the generation. Generate the route and calculate the route. You can enable it on the intelligent timers. Okay, so a hello interval, that interval, BFD for ISIS, fast flooding, timer for SPF, and timer for LSP generation. This is meant for calculation, and this is meant for the generation. This is for calculation. Okay, and this is for the generations. Okay, that's the difference. This is the default times. The first 1 second, 2 seconds. Following the initial millisecond, 50 millisecond, and incremental 100 milliseconds. Okay, so the value for the first digit is second. The last 2 digits is on the milliseconds. So it means that how fast they perform every second, they're going to perform the calculation, or every 2 seconds they're going to generations. Okay, let's say they figure out they keep on have a lot of information coming in. I'm going to increase 100 milliseconds increase 100 milliseconds. I keep on increasing until certain limit. I will just delay the generation. Because let's say your link is flat, I'm going to increase up to certain level. I'm going to stop, and I will not sending any. I'm not generating. I also will not calculate any information. I will hold for a while before I really calculate or generating. Okay, that is where there can be prevent on the route flapping in your ISIS environment. And the last one over here is on the security planning. Okay, security planning. In ISIS support 3 authentication mode: interface authentication, area authentication, and the domain authentication. Okay, interface, area, and domain. So I think this one in the HCIP they did cover a little bit, but it's not in detail. For the interface authentication, it's more into the IIH, the Hello authentication. Okay, a Hello authentication. Under area authentication, this is under LSP authentication. Okay, the link state PDO authentication. Domain authentication as well is using LSP authentication. The difference between the area and domain: area is for level 1 LSP. For domain is level 2 LSP. Okay, so means that let's say you're running all the level 2 routers, you have to enable the level 2 LSP authentication as a domain authentication. Let's say it's purely running level 1, they can just using the area authentication. So this is how the security planning that need to be done. Okay, and they have 3 type of authentication mode support both the simple password and MD5 authentication. Definitely for MD5 offer the higher security, and that is the recommended. Okay, that is recommended. Is that all right? That is on the planning on the ISIS so far. Is that okay? Any other question from here on the security planning? And next, that is on the typical live network configuration. So normally they have a defined with only one single level. They define this is on the cost style wide, and the circuit cost 100,000 level 2. Okay, they set into the calculation from here. Network entity, the name. So let's say you found that this is very difficult to remember, you can change them as a name. Okay, IS name, city equipment room device name. So you can change the name instead of just remember the entity. Entity is a bit difficult for you to remember because it can be up to 20 byte long. Okay, and you can set the preference of the ISIS route. Log peer change. Any changes happen, I'm going to alert to the NMS. Okay, it is called log peer change. Maximum loop balancing, the maximum for the maximum of the LSP aging, refresh of the LSP. Okay, this is on the seconds. Okay, seconds. And enable the multi topology. Set the preference on the IPv6 and set the loop balancing, and the circuit cost of the IPv6 is 100,000. So that's what it can did on the globally, and we did on the interface. So they can be very complex. You see that under interface, I have a V4 and also I have a V6, and I have link lockers. So I enables ISIS, enable IPv6 ISIS, and also they will have a circuit type, can change to point, which level you are. Interface cost level 2 on the V4 and the V6, and also sending the small hellos. So that is where we can define on the interface. So this 551, this is a process. Okay, process. So it means that the 551 by right, let's say you want to map this, it should be defined as a 551 here. Okay, they must be tied to the same process. That's what you define, where you're advertising into. Okay, V4, V6 can be running in the same process. It's not like OSPF. They are dedicated different database they're handling into. Okay, OSPF v6 cost, the cost on the levels and also cost on the v6 levels. So that's where what with the live network configured. But into our lab exam, they do not test up to that in that. But in the live environment, this is how it works. But for the lab exam, you need to know how this ISIS IPv6 is being configured, how you advertising this information into ISIS. All this information you still need to grab some ideas first. Okay, and this is what we go through. Later, I will send you the lab, and we're going to do it together on the ISIS IPv6. Okay, so that is on the summary for this topic. We covered about the advanced IPv4 ISIS features, and we'll go through the basic principle and the configuration of the ISIS v6 and how the configuration is being done. We have a multi topology. We have the also the basic feature functions. What are TLV they added in to support on the IPv6 ISIS, and the typical live environment. What type of the application cases they're going to use on the dual stack ISIS. Okay, that is where we are focusing just now. And now I'm going to share you the lab, and we're going to perform the ISIS IPv6 together. Let me open up the lab first on the ISIS. So I'm not sure that the lab that yesterday that I shared to you, is it still they using that? So maybe we can just doing from there to continue with the ISIS IPv6. So in this case, you can see that they have two topology on top. Let me show you the topology again. Yesterday that I shared. It's on the route linking as well, but let me just see whether I have another one. Hold on, let me just open up the new one. Let me start the device first. I'm going to share you another one. Hold on. My device is very slow. 20% more, okay? All right, let's start that ready. Just bear with me a while. Okay, to make sure that you are able to follow this let me just save one more file for you. This on the ISIS lab. So I say another one is called ISIS IPv6. Can you just open it, download that, and open it up? Then we can use that as our configuration for this ISIS IPv6. So at least that this information that I share right now, I have a IPv6 configured already. So do not need to do on the IPv4 and v6 together. So v6 address already predefined. So what we need is just advertise from the devices. Okay, that's how we're going to show you that how the IPv6 ISIS to be configured. Is that okay? Okay, started. Let's get started. Then I can show you that how we define on the IPv6 ISIS. Ready? Everybody started ready? So let me define from here. This is all the address I have from here, sir. R1, R2, R3, R4, and also R5. So I have all this information has been created. And first, I'm going to define on the V4 and V6 together, enable together. So on R1, R2 is on level 1. Okay, so right now, let's say we just do it on IPv6 first. IPv6, then only IPv4. Okay, so for ISIS, I think yesterday that I already showed you that how it be defined. You remember they have a one notepad that how we configure on the ISIS. It be very similar, just that right now we just have one few extra step. Okay, this is still the same network entity 49 once. Okay, this is still the same. And just that you want to enable the TLV, IPv6 TLV, you need to do this IPv6 enables. Okay, just have to done on this. and going to the interface gate 001 ISIS IPv6 enables 1. Okay, interface gate 00 ISIS IPv6 enable 1, and interface loopback 0 ISIS IPv6 enables 1. So instead of just ISIS enable, right now you need to add a MIDAS considered as a IPv6. Let's say refer back to the document that I showed yesterday. So what we're going to do from here is you just have to add a line. Okay, this is what I'm going to do into the router number 1. Okay, actually just add a IPv6 enables and IPv6 enables inside the interface. So the configuration actually nothing much difference compared to the IPv4. Is that okay? Okay, so that's router number 1. So I go to router number 2. I do the quick one from here. Just ISIS 1 network entity 49001. Yeah, that is how I doing on the router 2. Is that okay? Do you want me to keep this information into the notepad as well for your own reference?
Yes, okay. Yes.
Oh,
Okay.
okay. So in this case, I think I better to build another new document. Okay, this on the router number 2. So I can continue with router number 3. Let's say I want to follow, you can follow on the notepad. So I define router number 3, ISIS1. Okay, that is on the router number 3, ISIS1, using IPv6. Okay, so I copy this into the notepad, then continue the router number 4. Okay, 4 and 3 is be similar. Okay, this is on the router number 4. So actually nothing much difference compared to we did on the IPv4. Okay, yeah, this one is straightforward. Then router number 5. Okay, and this is for the router number 5. Remember, this is 49002. This is the difference, is 49002. Okay. All right, after it's done, I'm going to check the result from router A. Okay, router A. Display ISIS LSDB. Okay, display ISIS peers. So you can see that I do not need to display IPv6 ISIS because they are using the same information. So from here, you can see that I've learned on the ISIS information. This is my database. Okay. So do you still remember what you mean by the 01 here, 02 here, and 04 here? Okay. This 01 for a dot 1, 01 for dot 2, 01 for dot 4. This 01, it means that the pseudo node that is on the DIS. Okay. This is a DIS. This is a DIS, and this is a DIS. The 00 behind is to the LSP fragmentation. Right now, they have no fragmentation yet. For between all the LSP they send is still within the 256, so they have no any fragmentation is been created in this case. Okay, and they have an asterisk. It means that is your own LSP. Okay, your own LSP. So from here, it'll be pretty straightforward. It's not like in OSPF. In OSPF, you still need to know that this is a type 1, type 2, type 3. But in ISIS, it's not need to be know all this stuff. You just have to know that it's a level 1 or it's a level 2. Because router 1 is a level 1 devices, you only have level 1 database. Okay, that is on the whole times, and this is the LAN, and this is on the extra bit behind. ATT, P, and OL. So we focus on the ATT bit here. You can see that these two, they have ATT bit 1. What I mean? 3 and 4. Why we have an ATT bit as 1? So this one, I think that you already mentioned into your HCIP. This ATT bit is called attached bit. To tell that this router are attached to the level 2. Okay, it's attached to the level 2 routers. So it means that router 3 and 4 are attached to other areas as a level 2. So they will offer themselves, hey, I'm the one who attached to the other areas. Let's say you want to go to other areas, you just point me as your next hop or as your gateway to go to the destination. This is what it means over here by using the attached bit. Attached bit, just to tell that right now I'm the one who communicate with other areas. Let's say you want to go to other area, you point me as your default gateway. Okay, default gateway. That's why from here you can check in detail on the LSDB. Okay, from here you can check level 1s for the numbers. The string is on the 000004. Okay, Woodboss. I checked on the router 4. Okay, This is on the 004. It sent the LSP to me. Inside the detail, it tell me that they belong to the area 49001 in my same area. So that is the addresses. The interface address V6. Okay. Remember, this is on the TLV they added in. This is the TLV, and this is the reachabilities. Okay, the reachabilities. This is on the interface addresses. So that is what they are shared. Inside a LSP, they can be shared in total up to 16 IPv6 addresses. Okay, and going to these two destinations, they have a cost of 10 or cost of 10. Okay, and from here I know that this attached bit is 1. Okay, that's information inside the LSP, inside the database. Inside the database, they have a V6 TLV, the reachability TLV, and also the interface address TLV information is all inside my database. So, and on router number 1, I displayed IPv6 routing tables. Yeah, this is all the route that I learned. So you can see on the first colon is pointing to the FE802E0 FCFF FE57 7EAD. So who is these devices? It's a router 3 link local addresses. Okay, router 3 link local addresses. Let's say I check in this case. I check display ISIS LSDB 000000003.00. Okay, so I will get the information on the verbose. Okay, I will have the sorry about that. Let me just answer a call first. Hold on a while. Yeah, sorry about that. All right, so let me just come back to this for the configuration to show the database. Display ISIS LSDB level 1. Oh, okay. So this is the information that I learned from the router 3. Yeah, learned from router 3. So that's the information that I have 2001 35 colon 3, 13 colon 3, 3 colon 3. And this is the information that's standard topology right now we are using. And this IPv6 information. So from here, let me check displayed IPv6. So from my IPv6 neighbors, I have 2 neighbors, gate 00 and gate 001. Okay, so always when we forward based on the default route is always point direct into the next hop. So just now you see that this is the destination, right? When I display again, display IPv6 routing tables. There is my default route. It's going to this destination. So it means that is my neighbors, my routers on gig 001. This is the link layer addresses. This is where I forward my next hop to. So it means that similar to IPv6, when you connect to the next hop to the destination, always you point the next hop link local addresses. Okay, next hop link local addresses. So similar to this. So when I want to go to 2001 35 : where's the 35 : 35 : is over here. It's between router 3 and router 5. So router 1, you point to who? Point to R3. Okay. Let's say I go to 45 : this is my destination. Okay, this is my destination. I will go between 10, 10, 10 using the router 2 as a next hop, the 2 EED. So how I know that? You can display IPv6 neighbors. I know that under a gig 000, this is my link local addresses for me to point as a next hop. Okay, in this case, it's a bit difficult for really refer to the routing tables because of it's a huge range or the list of the tables we're going to be refer one by one for us to get the detail go up to the destination. So from here, let's I go back to router 1 first. I'm going to do a ping IPv6 and go to 2001 : 5 : 5. Okay, so it's able to passing through traced IPv6 2001 : 5 : 5. So you see that which way they're using. They're using 2001 : 13 : 3 or 2001 : 5 : 5. Or let's say I go to the 45 : 5. Okay. : 5 is on the router 5. Yeah, this is the destination. They go to router 2, router 4, and destination. But actually, the next hop they use is still using the link local address, similar to the OSPF v3. Whichever they go out, always the next hop is on the link locals. The next one is link locals. So they're having the same function that, remember that we have a route leaking on router 4 to import whichever detail back into the router 1. We also can do the same things because we found that this is a better path. Let's say I go to R3 on the interface, gate 000, display this, and let me set the ISIS IPv6 cost to 30. Okay, this I set is a 30. It must define is either it's IPv4 cost or IPv6 cost. Okay, I define IPv6 cost over here, and you also can specify this. You still remember how we're going to enable the multi topology? So you can also enable like this under every single routers. ISIS1 IPv6 enables topology. So they have IPv6 standard or compatible. So default running standard, let's say right now I'm using the IPv6. Okay, I enable IPv6 as my multi topology. Over here as well, ISIS IPv6 enables topology IPv6. Okay, I'll just do a quick one. Yeah, just to allow them to have two different topology calculation. That's why then when I set the cost, they can set the cost between IPv4 and IPv6. When they're going to the SPF calculation, they will have a split of the calculation between IPv4 and IPv6. Okay, so whenever I change this now, when I do this cost, it's only affect on my IPv6. It will not affect into my IPv4. All right. So this on the router 1 to router 5. After I done this, on router 4, I can do this. I can set that inside my ISIS1. Before that, let's check on R1. Display IPv6 routing tables. I check on 2001 colon 5 colon 5. So you can see that for me to go to this is the best. Default route is the best. Okay, default route is the best for me to go. Router 4 right now I'm going to import ISIS 1, import route ISIS level 2 into level 1. So you can see that from here, let's check again. Okay. You still can't see anything. Display ISI, import ISIS from level 2 into level 1. My mistake, I have to put IPv6 in front first to import route. So you need to put IPv6, import route ISIS, level 2 into level 1. Okay, you need to do as a V6 level, not V4 levels. So I lay back on router number 1 and check the information. And now they show me the detail. By using this detail, how I go to 2 EED. Instead of go to 7 ED, right now I go for 2 EED. Because this is my specific route. Specific route, go to the destination. Is that okay? So from here, what I did just now, I on the router number 4, I add this into the ISIS. IPv6 import route ISIS level 2 into level 1. This is what I did. I add this information, and also on R3 under gig 000, I have set ISIS IPv6 cost to 30. This is what I define as well. And all the device, I have added this. I've added IPv6 enables topology IPv6. So this is why I added into all the devices to support multi-topology. Okay, that is what has been done. So it's about the time right now. It's 11:35 already. Let's take a quick break. Come back. I'm going to show you that how the multi-topology works. I'm going to enable IPv4 as well. I'm going to show you that the calculation between V4 and V6 can be different. Okay, by using the multi-topology. Okay, let's take a break. Then come back. We're going to continue with this in it later. Just I think another 5 to 10 minutes only for this lab. Okay, but let's take a break for now. From 11:35, okay, we come back at 50. Then we continue. It's all right.
Okay.